Hi, everyone. Today's lesson is on very important trigonometry vocabulary, also reference angles and finding values around the unit circle. So there's a lot to do today. So we're going to get started. First thing that we're going to talk about is a little bit of a warm-up. And so just warming up, shooting free throws, okay? So in this problem here, you have the eyes of the basketball player. He or she is 6 feet up. The player has a free throw line, which is 15 feet across from the actual basket, and the basket is 10 feet up. And so your job is to find this angle in here. So you're looking for the angle of elevation that the basketball player needs to look up in order to get the ball in there to help them. This is going to be 4 feet because you have a full 10 minus 6 is 4. We're going to use tangent of an angle. So we're going to say tangent of an angle is equal to opposite over adjacent. For this problem, we are going to solve for theta or angle. This value right here, what I'm saying is theta. That's just another form, a symbol for angle. So tangent of theta is equal to 4 over 15. Remember, when you're getting theta by itself, you're isolating the theta. What you need to do is to get the tangent to the other side. What you're actually doing is finding the arc tangent of 4 over 15, because when you're moving tangent to the other side, you're taking its inverse. It's very similar to just like an equation where you have x plus 7 equals 10. And if that's the case, in order to get 7 to the other side, you're going to do the opposite or the inverse of add 7. So the inverse of that is minus 7. So that's the same type of thing that we're doing, okay? So you're going to find arc tangent. So do make sure that your calculator is in degree mode. So that's really important. I'm going to find arc tangent. Oops. So let's see here. We're going to find arc tangent of 4 divided by 15. My answer is about 14.93. So theta, the angle of elevation, is 14.93 degrees. Okay, now if you didn't have a calculator, this would actually be your answer. You would just use this right here as your answer if you weren't allowed a calculator. But if you do have access to a calculator, you would just simply make sure your calculator is in degree mode and then arc tangent. So some basic vocabulary. What's the definition of an angle? An angle is the union of two rays, has a common endpoint called the vertex, okay? All of our angles that we're going to be drawing regarding the unit circle will be on an axis that looks like this, and they won't be in this shape. They'll be coming from this center, which is the origin, and your angle will either look like this, it will look like this, your angle will look like this, or your angle will look like this. Okay, all your angles will look like this. They're all gonna be coming back to the x-axis. And we talked about this in previous videos, that all of my values, every time I go into a different quadrant, remember this is quadrant 1, quadrant 2, this is quadrant 3, and this is quadrant 4, all of my angles, regardless of what they are, will end up coming back to the x-axis, always the x-axis. So what we have is standard position. Standard position is this whole thing right here, which is I was just pretty much talking about it just a second ago. When you have an angle, when you draw an angle, okay, you're going to draw it based on 0. You're always going to start here. We call this ray the initial side. We're starting here. Now, if I'm in the first quadrant, my angle is going to be right here. There's my angle, okay? And that would be something that's under 90 because there's 90 degrees. If I'm in the second quadrant, my angle will be over here, okay? Either way, it's going to end someplace. So if I was at 50 degrees, let's say, this would go from here to here. This ray is actually called the terminal side. That's the terminal side, okay? Because that's where it ends. This side here, where it begins, is the initial side. If I'm talking about, let's say, something similar to this, like that, let's say this is 120 degrees, right? It's in the second quadrant. It's more than 90, but less than 180. Again, initial side, terminal side. The whole angle, that's just in standard position. Okay, so there's a couple of different things. You always start, again, at 0. Okay, 0 is on the x-axis right here. All right, so what we're talking about here, these are reference angles. So in trigonometry, we often think of an angle as a rotation. To do this, you think of placing a ray along the positive x-axis. Again, that's your initial side. Think of making a copy of the ray, rotating it, and now we're going to rotate it. Let's say we're going to take this angle, we're rotating it up here. That's my terminal side. Now, a reference angle comes into place. We talked about this in the last video, but if you didn't watch that, you have theta reference. Now, that's one way of writing it. You also could write it like this, a reference angle with like the little REF down here. But a reference angle is going to be less than 90 degrees, but more than 0 degrees. The angle that's formed to be in standard position, okay, that's just the standard position of the angle. We call that theta. Remember, we can say theta. So I'm going to say theta. You could say alpha. You could say omega, phi. You could say beta. All of these are Greek letters, symbols for angles. So you can use any one. I usually just use theta. Okay, so we know this is quadrant 1. We know that's quadrant 2, quadrant 3, and quadrant 4. Okay, what I want to talk about are reference angles. Now, reference angles are angles that are less than 90 degrees, but more than 0 degrees. So if I have an angle in standard position, and let's say that's 50 degrees, and I traveled up 50 degrees to get to this terminal side, how far do I have to travel to come back down? That's going to be 50 degrees. So in my first quadrant, theta is going to equal my reference angle. So the question that you may see is, well, what's the reference angle? Well, the reference angle in the first quadrant would be 50. Now let's keep that same, let's come over here to this quadrant here. And so let's say I have a 120 degree angle. And I went from here, because you always start at 0, you go from here to here. What's my reference? I want to know how far does it take me to get back to the x-axis. You are always going back to the x-axis. Well, if this is 120 degrees and this right here is 180 degrees all the way over here, this angle is going to be 60 degrees. So keep in mind, you would write it, you would say, well, theta is 120 degrees, but my reference angle is 60 degrees. So that's the correct way you would say that, okay? In the third quadrant, okay, let's say I draw an angle, I'm down here, and let's say this angle that I just drew was theta is equal to 200 degrees. Well, how far does it take me to get back up to the x-axis? Well, in this quadrant, in the left quadrant, third quadrant, I would say, well, that's theta minus 180 degrees. That's going to give me my answer. So that would be 200 minus 180, right? 200 minus 180 is just 20 degrees. So my reference angle would be 20 degrees. And lastly, if I'm in the fourth quadrant, okay, so here's my graph. Let's say I'm making a 300 degree angle, all right? So that means theta is 300 degrees. What's my reference angle? Now remember, your reference angle is always going to bring you back up to the x-axis. So if this is 300 degrees all the way around, how far does it take me to get back up to the top? Well, that's going to be 60 degrees. Okay, so I know we talked about this a little bit in the last lesson again, but let's go back over this. So coterminal angles are angles that end in the same place. That's what they are. So if this is my initial, so I don't know if you can see this, and this is 90 degrees. I want to end, this is 90. How do I get back there? Give me another coterminal angle that would end in the same place. So I could say theta could also equal, go all the way around once, 360, plus 90. So what's 360 plus 90? Okay, so that's going to be what? 450 degrees. So theta could equal 450 degrees. What if I went the other way and I said, okay, well, I'm going to go from here. Again, always start at 0 and go this way. Okay, what's 360 minus 90? Well, that's going to be 270. So another angle would be 270. However, do you notice how I went down instead of going normally counterclockwise? That means this angle here is going to be negative. Let me redraw that. So this angle here is going to be negative 270 degrees because I'm going down. I'm going this way. See that? Going down negative 60 to get back to this angle here, I could do this and I could say, well, that's positive. So theta could be positive 300 degrees. Or I could start here at 0 again and go all the way around once. That's 360 and another 60. Well, what's 360 plus another 60? Okay, so that's going to be 420 degrees. So I could say theta equals negative 420 degrees. So you coterminal means that they end in the same place. Okay, that's what that means. Okay, to get to here, you could go 360 minus 135. That's going to end in the same place. Remember that theta will be negative. Likewise, I could also, this just from here to here is 135, but I could go all the way around once at 360 and then go around once or twice, but go around and add 135. That's going to give me another angle. To end in the same place here, here's 0 degrees. I would go all the way around. That's 360. I could also go negative 360. So those angles are coterminal because they end in the same place. And I just talked to you about reference angles in a previous slide. Remember, I want you to notice no triangles are on the y-axis. Everything goes back to the x-axis. So if I have a 60-degree angle, come back. My reference angle is the same value. Theta is equal to theta reference. In quadrant 2, right? Quadrant 2, your reference angle is this right here. So that's going to be 180 degrees minus whatever theta is. In quadrant 3, all right, always go back to the x-axis. This goes up, that came down. For this one, you would go theta minus 180 degrees is going to give you your reference angle. And in the fourth quadrant, it's always going to be 360 degrees minus whatever the angle is that they give you. This is kind of interesting. We're going to be doing a lot of this later on, but this is what's called ASTC. This is All Students Take Calculus. It's a mnemonic, like Holmes, like SOHCAHTOA. It's a mnemonic. It's something to help you learn something. And so what this says is, in this case, A stands for all sine, cosine, tangent. Everything is positive. Every sign is positive. Everything else is negative. In this quadrant, tangent is the only thing that's positive. Everything else is negative, or tangent and cotangent. And then this is sine in its reciprocal function, which is cosecant. In the fourth quadrant, cosine and its reciprocal function secant are positive. So that's what it's talking about, is positive. Now, what you would be seeing something like this for would be, let's say I'm talking about sine of 60 degrees, or let's talk about 60 degrees. In the first quadrant, if this was 60 degrees, that's your root 3, here's 2, here's 1. Sine of 60 degrees in the first quadrant is opposite over hypotenuse, so root 3 over 2, okay? It's positive. And then so is cosine and so is tangent. But in the second quadrant, right, same problem, 60 degrees, right? You have the square root of 3, you have 2, but this is negative 1. In the second quadrant, sine is root 3 over 2, opposite over hypotenuse, right? So sine of 120 degrees is root 3 over 2. Again, I'm going to get the same answer all the way around, except for some of these may be positive or negative. So whichever quadrant I'm in, whether it's 1, 2, 3, or 4, the root value, root 3 over 2, is going to be the same. What's going to change is the positive and negative values. So, but in this quadrant here, the second quadrant, you'll notice that if I said tangent, find tangent of 60, which is opposite over adjacent, that's going to be in the second quadrant because only sine is positive. That means cosine and tangent are negative. In the third quadrant right here, right, another 60 degrees, this is negative 1. Across from 60 would be negative root 3, and here's 2. By the way, your hypotenuse is always positive. In this quadrant, if I were looking for sine of this value, 180 plus 60, so sine of 240, that's going to be opposite over hypotenuse, negative root 3 over 2. Notice, it's still a 60-degree reference. My core value is the same, except for this is negative because all students take in this quadrant, only tangent is positive. So therefore, sine is negative. And in this last quadrant, all students take calculus, only cosine is positive. So that means if I find sine of 300 degrees, this is going to be the same. So so there's 60. So that's going to be so that's also going to be negative root 3. Okay. So we're going to try to find reference angles and also the value. So in the first quadrant, right, you have 1, 1, square root of 2, because this is a 45-degree angle. Sine, this is going to be a reference angle of 45 degrees, because you went up 45, you're coming back down 45. If they want to know what sine is, it's going to be root 2 over 2, because that's opposite over hypotenuse. In this quadrant here, here's 135 here. That's 135. The reference, get back to the x-axis where it's at 180, is another 45 degrees. Again, this value is going to be root 2 over 2. Sine of 225 is going to be in this quadrant down here. Okay, getting back up to the x-axis is another 45-degree reference angle, not the angle, but a reference angle. Again, negative 1, square root of 2, because you went left, negative, down, negative. So sine is going to be opposite over hypotenuse. That's going to be negative root 2 over 2. And lastly, sine of 315, again, 45-degree angle, reference, okay, 1, negative 1, root 2. Sine in the fourth quadrant is going to be negative, which is square root of 2 over 2. So in this value here, this is just what we just talked about with sine, cosine, and tangent. What functions are what? We just talked about 45-degree angles. In this case, what's positive, what's negative. In this, usually this is always going to be cosine and then sine. Cosine and then sine. Cosine, sine, cosine, sine. So positive and negative functions. So in this quadrant, both of these are positive. In this quadrant, see, all students take calculus. In this quadrant, sine's positive. So that means everything else is negative. In this quadrant, only tangent is positive, which means that both cosine and sine are negative. In this quadrant, only cosine is positive. So that means sine is negative. So that's just a little trick to show that. So for this problem here, your job is to find the 6 trig functions and then find theta and then the reference angle. So it says I'm in quadrant 1, so I'm going to draw my angle in quadrant 1. Here's theta. Sine is opposite over hypotenuse, so that's 2 over square root of 5, opposite over hypotenuse. Let's see, x squared plus 2 squared equals the square root of 5 squared. So that's what, 5 minus 4. Well, that's 1. Square root of 1 is 1. All right. So the 6 trig functions, we have sine. So we're going to go cosine of theta is going to be adjacent over hypotenuse. That's going to be root 5 over 5. Tangent of theta is going to be opposite over adjacent. Remember, you're always putting yourself at the angle. You're always there at the angle. There you are. Tangent is opposite over adjacent, so that's 2. Cotangent of the angle is going to be that flipped over, so that's going to be 1/2. Let's move this down. Let's see, where are we at? Cotangent, secant of theta, which is the reciprocal of cosine, so that'll be root 5 over 1. And cosecant of theta is going to be reciprocal of sine, and that's going to be root 5 over 2. Now, that's the 6 trig. Those are the 6 trig functions. Now I just need to find theta. This one looks like it's the easiest one or the quickest one to do. So I'm going to get theta by itself. I'm going to go theta equals arc tangent of 2. Okay, so let's find what that is. So I'm going to go to my arc tangent of 2, and I get 63.4. So that tells me that this value, theta, is going to equal about, because I rounded, 63.4 degrees. This happens to be my reference angle and my angle. So theta is equal to 63.4, and theta reference is 63.4. Okay, so I've got my angle and I've got my reference angle. And in the first quadrant, those angles are the same. Now, in this one right here, it says, suppose sine is in the third quadrant. So in the third quadrant, I'm going to draw my angle. Okay, here I am. And then I'm going to go back up. Okay. Actually, I'm going to move this over just, for heaven's sakes. Okay. And so it says sine is opposite over hypotenuse. Here's theta reference. So opposite over hypotenuse, so we have -4 over 7. So what is that going to be? 49. So that's square that. 49 minus 16 is 33. So this value here is the square root of 33, except this is negative. Okay, because you're going to the left. So 6 trig functions. We've got sine of theta. Now let's try to find cosine of theta, tangent of theta, cotangent of theta, secant of theta, okay, secant of theta, and cosecant of theta. Okay, so cosine is adjacent over hypotenuse, so that's going to be equal to negative root 33 over 7. Tangent's opposite over adjacent, so that's 4 over root 33. Don't leave it like that. So you have 4 root 33 over 33. Cotangent is going to be root 33 over 4, because that's a reciprocal function. Secant is the reciprocal of cosine, so that's going to be -7. So that'll be -7 root 33 over 33. And cosecant is a reciprocal of sine, so that'll be -7/4. Okay? So for these, so now all I got to do is find theta. Well, I'm going to use arc cos, which one am I going to use? Sine. I'll just use this original one. So that's going to be theta is equal to arc sine of -4/7. So theta, let's see, sometimes theta is the whole angle, but most of the time it's the reference. So we're going to go trig function, arc sine of -4 divided by 7. And I get 34.8. You probably are looking at your calculator and you're going, wait, nope, I got -34.8. But you need to remember that what you just found was this angle right here. That's what you just found, okay? That angle is your 34.8 degrees. Reference angles are between 0, okay, and 90. More than 0, less than 90. Can't be negative. So my reference angle in this problem is about 34.8. But you got to ask yourself, can that possibly, 34.8, can 34.8 possibly be my actual angle? Okay, that's what you're asking yourself. And you should know that, look where you're at. To get from here all the way over to here is no way going to be 34 degrees. Okay, this is 34 degrees. This little part inside here is 34 degrees. So what you would do is you would say, well, I know this from here to here is 180. Now I have to add 34.8. So my reference angle is 34.8, but my actual angle, which is theta, is going to be 180 plus 34.8 for 11 to 14.8 degrees, and that's theta. Okay? Find the 6 trig functions for the angle that has point 3, -6. So find 3, -6. So it's actually kind of important to draw this. I think it's important to draw this. So we're going to go over 3, 1, 2, 3, down 6. Okay, so 1, 2, 3, 4, 5, 6. Here I am. Okay, this is your angle. Draw your angle. Okay. Where are you supposed to go back to? You're going to go to the y-axis because it's super close. You're going to go up to the x-axis. Always go to the x-axis. Never go to the y-axis, even if it's super close. So here we are. Here's your right angle. Now, this is 3. This is -6. So to find the 6 trig functions, I just need the third side. That, my hypotenuse. So I can use, let's say, x squared equals 3 squared plus -6 squared. So that's x squared equals 9 plus 36. So x squared equals what? 45. So the square root of 45 is my answer for x. Oh boy, don't leave it like that. Square root of 45 is actually the square root of 9 times the square root of 5, which is 3√5. So my third side is 3√5. Okay, so let me just circle these because there's a lot of red over here going on. Okay, so finding, let's say, sine of theta, cosine of theta, tangent of theta, cotangent of theta, secant of theta, cosecant of theta. There's no order to this. You just put it how you want it. Sine of theta is going to be, where's theta? Theta is here at the angle. Theta is always, okay, here's my angle. Theta is always one of these angles around here, one of these. All right, so sine of theta is opposite over hypotenuse. So that's -6 over 3√5. Do not leave it like that. That'll be -2 over √5, which is -2√5 over 5. Cosine of theta is adjacent over hypotenuse. So that's going to be 3 over 3√5. That's going to be 1 over √5. Don't leave that down there. √5 over 5. Tangent of theta is opposite over adjacent. So that's -6 over 3, which is -2. Cotangent is a reciprocal function. So that's going to be -3 over 6, which is -1/2. Secant of theta is the reciprocal of cosine. So that's going to be this value. So it's going to be √5 over 1. And cosecant is a reciprocal of sine, which is going to be this value right here, which will be -√5, excuse me, over 2. So those are my 6 trig functions. Now I have to find theta and my reference angle. So pick one. I'm going to pick tangent. So what I know is this. I know tangent of theta is equal to -2. Get tangent on the other side. So theta is equal to arc tangent of -2. Theta is about, let's see what it is. Okay, so we're going to take arc tangent. Okay. We're going to take arc tangent of -2 going to get that value. I get 63.4. So it's a negative, but that's not negative. So my reference angle is 63.4 degrees, okay? Because it went down, they gave us a negative. Then on your calculator, this is what it says, okay? But what you need to know is this angle can be an angle if it was negative, but they want the positive value of the angle, which is this angle here, okay? So technically, we're going to go, that's going to be 360 minus 63.4. Oops, 360 minus 63.4. And that's what, 296.6? So theta, positive, is going to be 296.6 degrees or 63.4 degrees. Okay? This is also theta, but we always like to write it as a positive value. And so you would use this one, okay? So reference triangles, reference angles, sine of 150. So here we go. We start here, initial side, okay? Going around, terminal side. This is 150 degrees. My reference angle, 30, okay? Across from the 30 is 1. Across from the 90 is root 2. Across from the 60 is going to be your root 3. But because we're going to the left, right, that's negative. So sine of 150, cosine of 150, and tangent of 150. So sine is opposite over hypotenuse. So, whoops, that's not right. Hold on, let me fix that. That's not root 2, it's 2. Thank you. Sine of 150 is going to be 1/2, so that's 1 over 2. Cosine of 150 is negative root 3 over 2 because that's adjacent over hypotenuse. And tangent of 150 is opposite over adjacent, so that's 1 over negative root 3, which is going to be negative root 3 over 3. And my reference angle, so you go theta reference, is equal to 30 degrees. Here's some practice problems. Draw each graph in standard form. So if I draw this in standard form, from here to here is 175 degrees, okay? How far does it take me to get back? So if theta is 175 degrees, then my reference angle is 5. This is just 180 minus 175, which is 5. For this one, 130 degrees, we're going to start again at 0, all the way around to 300 degrees. That's 300. How do I get back up here? Well, that's going to be 60. So if theta is 300, then my reference angle is 60. Okay, negative 780. So let's think about that. That first of all, that has to go in the opposite direction. So this is negative 360. That's one time. Going around twice is 720. So now we're here. Now the difference between the two is the 60 degrees. So I got to go another 60 degrees down here. Okay, so there's my reference. So therefore, theta is equal to negative 780 degrees, but my reference angle is 60. Remember, reference angles are always positive and in between 0 and 90. No calculators. Your job is to find sine of 30, cosine of 30, and tangent of 30. So if this was 30 degrees, that's 1, 2, square root of 3. Sine of 30, opposite over hypotenuse. Cosine of 30, which is adjacent over hypotenuse. And tangent of 30 is opposite over adjacent, which is 1 over root 3. Keep in mind, in previous lessons, we were talking about cofunctions, okay? And the cofunctions would, and this should make sense to you, so think about this. Sine of 30 should be the same thing as cosine of 60. And cosine of 30 should equal sine of 60. So what I'm saying is I know that sine of 30 is 1/2, but so is cosine of 60. Okay, so just keep that in mind. That's a cofunction. Excuse me. Try to find the reference angle and exact function values for 225. So 225 is past 90, past 180, down here. So we're at 225 degrees. 225 degrees minus 180 degrees is going to give me 45 degrees. So now I'm down here 45, which is 1 square root of 2. Don't forget your negative signs, okay? So sine, cosine, and tangent. And so, by the way, when you write this out, you don't write sine of 45 degrees because that would be in the first quadrant. Remember, this is going to be sine of 225 degrees, cosine of 225 degrees, and tangent of 225. So sine is going to be, put yourself here at the angle. So sine is opposite over hypotenuse. So that's negative 1 over root 2, which is negative root 2 over 2. Cosine is adjacent over hypotenuse. So that's the same thing. So negative root 2 over 2. And tangent is opposite over adjacent, which is negative 1 over negative 1, which is 1. Reference angle for the exact function for sine of 1050. So I would go, what's 1050 divided by, 360, okay? That's going to give you 2 and some values. So twice around the graph, the unit circle, 2 times around that is 720 degrees, right? All right, so what's 1050? So what's 1050 minus? Where are we at? 1050 minus 720, 330. So what we did was basically this. They started off here at 0. They went around once, that was 360. They went around twice, that was 720. And then we still have 330 degrees left. So we're going to go past 90, past 180, past 270, here. Here I am. Where am I? I'm at a 30-degree reference, sine of 30 degrees. All students take calculus. Cosine is positive here. That means sine is going to be a half, but it's going to be negative. Tangent of 675, okay, where is that? So let's think about that. Once around is 360. What's 675 minus 360? So that's 1, what's that, 215? So we went around 1 time, and then we went around another 215 degrees, okay? There we are, right there, okay? So what's 215? Subtract 180, and we get, oh, is that right? Hold on. Where are we at? 675 minus 720. Oh, that's just negative 45. So that should be 45 degrees. It's late. Okay, so here we go. So that's going to be a 45 degrees. Think about what 45 degrees is. What's tangent of 45 degrees? 1. Opposite. So depending on what quadrant I'm in, right? All students take calculus. If tangent's in this quadrant, it's a positive 1 at 45. If it's in this quadrant, it's a negative 1. Tangent is positive in this quadrant, so it's a positive 1. And in this quadrant would be negative 1. So this one is a really interesting question, and I like this a lot. It says, I have a line that's 4x plus y equals 0. So we know that y equals negative 4x plus 0. Okay, we know that that's a line. We know it's a line that starts at 0, 0. And we know that's a line that goes down 4 and over 1. And so what that's telling me is, that's my point. I got to go back to the x-axis. Down 4, so that's negative 4, over 1 is 1. Let's find the third side. 1 squared plus negative 4 squared equals my x squared. So that's what, 16 plus 1 is 17, so that's going to be the square root of 17. So let's see here. 0, down 4. So it can't be in quadrant 2, can it? So we're going to start here. Down 4 over 1. This should be quadrant 4. Okay. Here's theta. So sine of theta, cosine of theta, and tangent of theta is going to be, sine is going to be opposite over hypotenuse, which is going to be negative 4 root 17 over 17. Cosine is going to be adjacent over hypotenuse, which is going to be root 17 over 17. And tangent is going to be opposite over adjacent. To find, and that's all you have to find. And then very similar problems. It says you're in quadrant 2, so you put yourself in quadrant 2 right there. And it says cosine of theta is negative 4, 6, so here's theta. Cosine is adjacent over hypotenuse, and this is perpendicular, okay, right triangle. To find x, you use Pythagorean theorem. And again, you got to find the remaining side, so you just go 36 minus 16, and that's 20. This is going to be the square root of 20, but keep in mind, that's root 4 times root 5, so that's 2 root 5. So here we go. Sine of theta, okay, is going to be opposite over hypotenuse, so that's going to be root 5 over 3. Cosine, so what does it want me to find? And theta, find the remaining trig functions. Okay, there's cosine, I'm just going to find tangent, and tangent is going to be opposite over adjacent, so 2 root 5 over negative 4, which will be negative root 5 over 2. You want to find theta. So, I mean, you have sine, you can use tangent, you can use cosine. I usually just use this one up here. So again, to find theta, you're going to go cosine is equal to, theta equals arc cosine of negative 4 over 6. So in this problem, theta would be, let's see here, arc cosine of negative 4 divided by 6. And that's going to be 131 degrees. Ooh. So if that's the case, theta is 131 degrees. This is theta, 131 degrees. That makes sense. Now, to find my reference angle, all I do is I go 180 minus 131 degrees, and I get 49 degrees. So theta reference is 49 degrees. So there's my reference angle, because that's this angle in here, 49. And then this is theta right there. And so this value, right, so this is kind of important right here. Your job is to find sine, cosine, and tangent. And this right here is one of the most important things you do need to remember. And so it's based on a unit circle. Okay, so here's my unit circle. If I'm thinking of this being a unit circle, what's this point? 1 unit over, that's going to be 1, 0. This point here is going to be 0, 1. This point here is going to be negative 1, 0. And this point here is going to be 0, negative 1. Okay, and your job is to figure out, well, what's sine, cosine, and tangent of these exact values. Okay. And what's happening here, if you remember in the previous lesson, this is cosine, this is sine. For everyone, cosine, sine, cosine, sine, like that. So if I were to ask you what's sine of 0 degrees, remember this is 0 degrees, you're going to say 0. Sine of 0 degrees is 0. Cosine of 0 degrees is 1. Now I'm here at 90 degrees. What's sine of 90 degrees? 1. So sine of 90 is 1. Cosine is 0. Now tangent is sine over cosine. So that's 1 over 0, which is undefined. Okay. Likewise, sine of 180. So I'm going over here to 180 degrees over here. Sine of 180 is 0. You're looking at the way that this goes. Cosine, sine, okay? Cosine of 180 is -1. Tangent is sine over cosine, so 0 over -1, which is 0. Sine of 270, we're right here, okay? Sine is -1. Cosine is 0. Tangent is sine over cosine, so -1 over 0, which is undefined. And lastly, back to 360, sine is 0. Cosine is 1. Sine over cosine is 0 over 1, which is 0. Now, that's all well and good. But I also want to show you a different way of doing this, okay? We have sine of x, and we have y equals cosine of x. If I were to unravel my unit circle, kind of throw it out there, okay? I'm going to get a sine wave. And my sine wave, and I'm going to get a cosine wave. And my sine wave is going to start at 0. It's going to go up, it's going to come back down, and it's going to end right here, okay? Now my cosine graph does the opposite. Well, this one, it's actually shifted 90 degrees. This is 1. This is -1 here. Cosine is going to start high at 1. It's going to come down, go down -1, come back up, end high at 1. Now, what you also need to remember is that, okay, what you need to remember is that this is 0 degrees and this is 360. That ends. Same thing, 0, 360. Halfway in between, I have this point, which is 180, right? Here's 180. Halfway between 0 and 180 is 90, 270. Halfway between here is 90. Low point here is 270. So now, if you were to unravel your sine wave, your unit circle, and you would have a sine graph and a cosine graph, okay? You could also just look at these graphs and figure out the same thing you did up here. So like if I said I'm at 0 degrees, what's sine of 0 degrees? Well, it's 0. See? Well, it's 0 degrees not on there. Sine of 90 is 1. See that right there? 1. Sine of 180 is 0, right there. Sine of 270 is -1, right there. Sine of 360, back to 0. Likewise, for cosine, you've got cosine of 0 is 1. Cosine of 90 is 0. That's right there. Cosine of 180 is -1. It's in a 1. And cosine of 360 is 1. So you have options on how to try to figure out which ones, you want to. A lot of students will like to draw the unit circle. And if I ask you what sine of 90 degrees is, they'll go, okay, 90 degrees is here. There's 0, 1. Sine is 1. So sine of 90 degrees is 1. Where other people will look at it and they'll go, okay, sine wave does this. Sine of 90, that's 1. Okay, so you have options on how you solve these, and that's good. So the last few slides here, I know this is a long video, but sine of 30 degrees, 1, 2, square root of 3. Sine of 30 is 1/2. Sine of 150, also 30 degree, is 1/2. Sine of 210, another 30, is 1/2, but negative, and this is also negative. Okay, because here's 30 degrees, it goes -1, 2, square root of 3, so sine is opposite over hypotenuse. Or you can remember that all students take calculus, and every sign that is in every quadrant is going to give you the same core value, but positive in the first quadrant, positive in the second quadrant. Only tangent's positive here, so that's going to be negative and negative here. 60 degrees, cosine of 60, here's 60, goes √3 here, here's a 30, right? 2, here's 1. Cosine of 60 is adjacent over hypotenuse, so we have 1/2. My core values are going to be the same. They're all going to be 1/2, okay? But in this problem, all students take calculus, positive first quadrant, second quadrant, only sine's positive, that's negative. Third quadrant, only tangent's positive, that's negative. Fourth quadrant, cosine, positive. So there's a unit circle song that I'd like you to watch. This is from my good friend Michael Bautista, and this is something that you can look up on YouTube. This is a really cool song that will help you learn the unit circle and the values, and we will be starting that next lesson. All right, thanks for watching, and I hope that helped you. Bye.